Right. Okay, Assalamualaikum and hi everyone. So this is chapter 1 on the non-linear equation. Alright. Okay. So let's say we have the equation or any equation the power is not equal to 1. Okay. So that is non-linear equation. For example, so we have a variable x, variable y, and also variable z. So let's say we have x with the power of 2. So this is non-linear equation. But if we have all the variable with the power of 1, then this is a linear equation. But other than the power of 1, then this is the non-linear equation, including if we have square root. Let's say this one square root. Okay, because square root we know the power is 1 over 2. So this is the types of the non-linear equation. So basically, we want to solve the non-linear equation, or we want to find the value for x. Let's say we want to solve the equation. So by using a numerical method. So in this chapter, we focus on the 3 methods: bisection method, simple iteration method, and also Newton-Raphson method. But first of all, please excuse my voice. Okay. Right. So this is all the subtopic that we need to cover in this chapter. Okay, I have mentioned just now the difference between linear and also non-linear equation. So for the first subtopic, for the root finding, okay, let's say we have this equation. Okay, we have let's say x squared equal to 4. Right. So the first step, what you need to do is you have to move all the equation to the left hand side. So we have x squared minus 4 equal to 0. Right. So now, after you make this this equation as equal to 0, so now you can make fx equal to x squared minus 4. Right. And then factorize. So we have x plus 2, x minus 2. So when this one is equal to 0, and then it's not equal to 0. So we have x plus 2 equal to 0. So x equal to negative 2. X minus 2 equal to 0. So x equal to 2. So means x negative 2, x equal to 2 are the roots of this non-linear equation. Okay. Alright. So we have one theorem. So IVT theorem. So why we want to apply this IVT? Because we want to verify the existence of the roots in a certain interval. Okay. Let's see. We have for example, we have x squared plus y squared minus 1. So in this interval, okay. So we apply this IVT. Okay, IVT theorem. So we want to verify, okay, is it exists the roots for this equation. So the first one will be A and this one will be B. Okay. So when FA multiply with FB, if you get negative answer, negative, less than 0, then the roots exist. But if the answer is more than 0 or positive, so no conclusion can be made. Right. So for the questions, let's say they ask you, by applying the IVT, show that there is a root in this interval. So you have to apply lah this theorem. Okay. Okay. Let's try one example. So use IVT to verify that question number 1 has a solution on the interval. Alright, okay. So the first step is, what you need to do is, you have to move all your equation to the left hand side. Equal to 0. So your fx will be equal to x5 plus 2x minus 1. So this is your fx, right? So on the interval, this is your a and this one will be your b. So you substitute. So fa is equal to 0, so negative 1. And fb, b is equal to 1, so 1 plus 2, 3 minus with 1 equal to 2. So now, if fa multiply with fb, so the answer will be negative, because negative 1 times with 2 will get negative 2. Therefore, there is a root in that interval. Okay, so this is how we apply the IVT to verify the existence of the root. Okay, now number 2. So number 2, the equation is already equal to 0. So we have our fx. So fx equal to 2x cubed plus x minus 5 equal to 0. Right, okay. So this is A and this is B. So F1, FA equal to 3 minus negative 2. And how about F2? Okay, F2, by using our calculator, 2 times with 8 plus 2 minus 5. So the answer will be 13. So if we multiply FA multiply with FB, still the answer will be negative. Therefore, there is a root in that interval. Okay, it's very easy. Just apply the theorem. Right.